Imagine holding a shiny zinc sheet in your hands. It looks simple, almost ordinary. But what if I told you that this thin piece of metal has survived temperatures hotter than flowing lava, traveled thousands of miles across continents, and passed through machines powerful enough to crush a truck? Most people never think about this, yet every zinc sheet hides one of the most fascinating manufacturing journeys on Earth. Look around you. Zinc sheets protect rooftops, warehouses, bridges, factories, electrical equipment, and even some of the world's tallest buildings. They quietly fight corrosion every second of every day. Think about this. Without zinc, millions of tons of steel would rust away every year. And this is where it gets truly extraordinary. Today, we're going far beyond the finished product. We'll travel deep into underground mines, step inside gigantic smelters, witness rivers of molten metal glowing brighter than the sun, and follow every step until flawless zinc sheets roll out one of the world's most advanced production lines. By the end of this journey, you'll never look at a simple metal sheet the same way again. Everything begins deep beneath the Earth's surface. The primary source of zinc is a mineral called sphalerite, containing up to 67% zinc sulfide. Huge deposits lie beneath Australia, Peru, China, Mexico, India, Canada, and Kazakhstan. Imagine miners working nearly a kilometer underground where temperatures naturally reach over 40 degrees Celsius before machinery adds even more heat. Modern drilling rigs break apart solid rock using hydraulic force and diamond drill bits. Every blast releases hundreds of tons of zinc, or that loaders immediately collect using machines weighing more than 50 tons. Conveyor belts carry the ore through kilometers of underground tunnels before giant elevators lift it toward daylight. The noise is thunderous, and the air smells of wet stone and freshly fractured rock. But here's what nobody tells you. A truckload of freshly mined rock contains surprisingly little usable zinc. In many mines, the ore contains only 5 to 15% zinc. That means operators must process nearly 20 tons of rock just to recover a single ton of valuable metal. Most of everything they dig never becomes part of the final product. The crusher enters an enormous processing plant where rotating crushers and ball mills grind the rock into powder finer than beach sand. Water mixes with chemical reagents inside flotation tanks. Tiny bubbles attach only to zinc minerals, carrying them upward while unwanted rock sinks to the bottom. Watching this process feels almost like seeing magic happen inside industrial machinery. After concentration, the zinc-rich material reaches an impressive purity of nearly 55 to 60%. Massive filter presses squeeze away excess water before the concentrate begins another incredible journey. Freight trains stretching nearly 2 kilometers long transport thousands of tons toward giant smelting facilities. Every shipment travels hundreds or sometimes thousands of kilometers before production even begins. Think about this. Producing 1 ton of refined zinc requires enormous amounts of electricity and careful environmental management. Modern facilities recycle processed water, recover sulfur dioxide to manufacture sulfuric acid, and capture nearly every particle before it reaches the atmosphere. Today's smelters are engineering masterpieces designed to produce more metal while creating less pollution than ever before. Now the real transformation is about to begin. The concentrated minerals that arrived as dark gray powder are only moments away from becoming glowing rivers of molten zinc. What happens next surprised even experienced engineers, because inside the smelter, temperatures climb so high that solid metal begins behaving like flowing water. And that's where our factory journey becomes truly unforgettable. The zinc concentrate first enters a massive roasting furnace operating at approximately 950 degrees Celsius, 1,742 degrees Fahrenheit. Powerful fans force hot air through the furnace, converting zinc sulfide into zinc oxide while releasing sulfur dioxide gas. The entire building vibrates with the roar of burners and giant exhaust systems, and the heat radiates through every steel beam. This critical reaction prepares a material for extracting pure zinc. Next comes purification. The roasted material dissolves inside giant leaching tanks filled with sulfuric acid heated to nearly 60 degrees Celsius, 140 degrees Fahrenheit. Huge agitators spin at around 80 revolutions per minute, mixing thousands of liters every minute. As impurities separate from the solution, Engineers continuously monitor chemical balance using automated sensors accurate to a fraction of a percent. Every second matters because even tiny contamination can reduce the final sheet's quality. Now electricity takes over. Inside enormous electrolytic cells, hundreds of aluminum plates hang inside purified zinc solution. A direct electrical current slowly pulls pure zinc atoms onto each plate over 24 to 48 hours. The room feels almost silent, except for the soft humming of thousands of amperes flowing continuously through endless rows of cells. Workers remove the finished zinc cathodes and transport them to giant induction furnaces. Here, the metal melts at approximately 420 degrees Celsius, 788 degrees Fahrenheit, before operators superheat it to around 460 degrees Celsius, 860 degrees Fahrenheit, to ensure perfectly smooth flow. The molten zinc glows like liquid silver under brilliant orange light, while robotic cranes move dozens of tons with astonishing precision. And this is where it gets truly extraordinary. The purified molten zinc enters a continuous casting machine that transforms liquid metal into thick slabs. Water-cooled copper molds instantly solidify the outer surface, while the center remains incredibly hot. Within minutes, a glowing slab weighing several tons slowly emerges, ready for rolling. Those heavy slabs move directly toward massive rolling mills powered by motors producing thousands of horsepower. Steel rollers rotate at speeds exceeding 300 revolutions per minute, squeezing the slab thinner with every pass. Each reduction must happen gradually, because forcing the metal too quickly could create microscopic cracks invisible to the human eye. The thunder echoes through the factory like rolling thunder. Between rolling stages, the sheets pass through controlled annealing furnaces heated to approximately 250 degrees Celsius, 482 degrees Fahrenheit. This heat relaxes the metal's internal structure and restores flexibility before the next reduction begins. Long cooling tunnels use precisely controlled airflow to prevent distortion, ensuring every sheet remains perfectly flat from edge to edge. Finally, precision finishing rollers polish the surface until it reflects light almost like a mirror. Automated trimming machines remove rough edges with tolerances tighter than plus or minus 0.15 millimeters, while laser-guided cutters slice sheets into exact customer dimensions. Every movement happens with breathtaking speed, producing hundreds of finished zinc sheets every single hour. Just when you think the process is complete, another challenge begins. Every sheet now faces advanced inspections powerful enough to detect flaws smaller than a grain of dust. What these intelligent systems discover determines whether the sheet reaches customers or returns to the furnace for another journey. Before a single zinc sheet leaves the factory, it passes through one of the most advanced quality control systems in modern manufacturing. High-speed AI vision cameras scan both sides of every sheet at speeds exceeding 120 meters per minute. Powerful LED lighting reveals scratches, dents, coating defects, and microscopic surface imperfections invisible to the human eye. Most people never think about this, but every square centimeter is inspected before approval. Laser thickness gauges measure every sheet with incredible precision, maintaining tolerances within plus or minus 0.02 millimeters. If the rolling mill produces even the slightest variation, the computer instantly adjusts roller pressure and speed. Thousands of sensors communicate with one another every second, creating a factory that almost thinks for itself. What happens next surprised even experienced engineers. The finished sheets undergo bend tests, impact tests, and corrosion resistance testing. Some samples spend more than 1,000 hours inside salt spray chambers that simulate years of harsh weather exposure. Others are repeatedly bent until engineers confirm the metal maintains its strength without cracking. Only the toughest sheets survive every challenge. Even with incredible automation, human expertise still matters. Skilled inspectors run their fingertips across polished zinc surfaces, feeling imperfections that machines occasionally overlook. Years of experience allow them to recognize tiny defects, simply by how light reflects across the metal. Sometimes the most advanced sensor inside the factory is still the human eye. Factories producing premium zinc sheets typically achieve rejection rates below 1.5%, yet every rejected sheet returns directly to recycling instead of becoming waste. Nothing valuable disappears. Every kilogram of rejected zinc becomes raw material for another production cycle. But the story doesn't end inside the factory walls. Every year, The world produces more than 13 million metric tons of refined zinc, with millions of tons transformed into zinc sheets and galvanized steel products. The global zinc industry generates well over $40 billion annually. Imagine stacking 1 year's production into sheets. They would cover entire cities with shining metal. China leads global zinc production, followed by Peru, Australia, India, and Mexico. Together, these nations supply a huge portion of the world's zinc demand. Millions of miners, engineers, metallurgists, truck drivers, machine operators, and technicians work together every day to keep this worldwide supply chain moving. Did you know that zinc protects more steel worldwide than almost any other corrosion-resistant metal? Did you know a properly coated zinc sheet can protect buildings for 50 years or more with minimal maintenance? And perhaps the biggest surprise of all, over 30% of the world's zinc supply now comes from recycled material, making it one of the most sustainable industrial metals on Earth. 50 years ago, producing zinc sheets required enormous manpower and relatively simple mechanical equipment. Today, artificial intelligence, robotics, automated rolling mills, and laser inspection systems produce stronger, cleaner, and more consistent products than ever before. Over the next decade, smart factories will become even more efficient, reducing emissions while increasing production to meet growing global demand. Today, you've traveled from deep underground zinc mines to roaring furnaces, massive rolling mills, intelligent inspection systems, and finally to the finished sheet ready for construction projects around the world. What looked like a simple piece of metal turned out to be the result of extraordinary science, engineering, and human determination. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.